Yum, yum!
William Vaughan here with a quick introduction to using linear and radial fall-offs in Modo. The effect any tool has on a selected region of geometry is rigid, meaning applications of the tool happen at a constant rate across the selected range. Simply put, components are either selected or not selected. If nothing is selected, then all elements in the active meshes are considered selected. We can use fall-offs to provide a way to attenuate the effect a tool has over a selection. Fall-offs enable you to gradually decrease the intensity of a tool across a defined range. You can access the various fall-off types by using the fall-off drop-down menu located above the 3D viewport or from the Edit menu under Fall-off. The easiest way to explain fall-offs is to see them in action. One of the most common fall-off types is linear. Once active, the fall-off properties are visible in the Tool's Properties panel as an adjunct to the tool's properties. Each fall-off has its own specific settings that you'll want to get familiar with to be able to take full advantage of the fall-offs. To define the range of the linear fall-off, simply right-click and drag in the viewport. The linear fall-off uses a straight line to define the fall-off. The line itself determines the direction of the fall-off's influence and the strength of the effect itself. All of the vertices at one end of the line receive 100% of the tool's influence, and the vertices at the other side receive 0% of the tool's influence. The points between the two lines receive some partial value based on the interpolation between the two endpoints. You can quickly reverse the influence of the fall-off by using the reverse option. The symmetric options enable you to mirror the influence area of the fall-off. You can also change the shape of the fall-off by taking advantage of the shape presets, which are similar to modifying the interpolation of one key to another in the graph editor. Several tools you might already use take advantage of linear fall-off. The shear tool, for example, is simply the move tool with linear fall-off. The twist tool uses axis rotate with linear fall-off and in the automatic type for its action center. The taper tool uses scale with the linear fall-off, and the flare tool uses linear fall-off as well. Using any of these tools should help to gain a better understanding of not only how useful linear fall-off is, but how it can be used to speed up the modeling process. Another common fall-off is radial fall-off, which uses a sphere where all vertices at the center of the sphere receive 100% tool influence, and any vertices outside the sphere receive 0% of the tool's influence. Just like the linear fall-off, you can change the interpolation style by using the shape preset attribute. If you've ever used Soft Move, you've simply used the Move tool with radial fall-off. Swirl uses radial fall-off combined with axis rotate and the automatic action center type. And the Bulge tool uses the Scale tool with radial fall-off to produce a swelling effect. Explore these tools or combine radial fall-off with other tools to expand your ability to manipulate your meshes with more control. Oh, look at the time.